Find the values of a and b in the given expression, and the expression is 7 plus root 5 upon 7 minus root 5, then minus 7 minus root 5 upon 7 plus root 5 is equal to a plus 7 upon 11 root 5 into b. Most of the students would be like, oh my god, I'm not going to do it. I cannot do it. It's so difficult. It's so complex. This is the first losing point. Don't do that. Without trying a question, never quit. You never know. The terms and the numbers may be placed in a way that finally they just cancel out each other in a few steps and you get the answer. So try it. And believe me, even this question, it is appearing to be quite complex, but it is not. Now, before moving ahead, a very common mistake that I have observed many students commit here is they would cancel out plus root 5 with minus root 5 and minus root 5 by plus root 5. No, this is wrong, because this 7 minus root 5 is a single term. You cannot just cancel out a part of it with another. You have to solve it. So, cancellation works only when you have the multiplication sign in between. Here it is not multiplication. It is addition. It is subtraction. So, you just can't cancel out the parts of a term where they are associated with plus and minus sign. It can be done only when you have multiplication, or even in division. You can take the reciprocal and do it, but not in this case. So this is a very common mistake. Avoid it. Don't fall for it, because once you get into the habit of this, your solution will be flawed right from the beginning. So let's get back to our original question and start solving it. Here, this is your LHS and this is your RHS, and both are equal. As we have done some of the previous questions, RHS looks almost simplified while LHS is not. So we have to simplify and reduce the LHS and bring it in a format that looks similar to RHS. Once we do it, we will be able to make the comparisons and pick out the values of A and B. And in this question, I am not going to separate out LHS and RHS. Rather, let's do the complete expression all together. So we have 7 plus root 5 divided by 7 minus root 5 minus 7 minus root 5 divided by 7 plus root 5 is equal to A plus 7 by 11 root 5 into B. You can put a bracket here just to avoid any confusion that may hamper with your process. So now we have a denominator here 7 minus root 5 and another denominator here 7 plus root 5. These are two fractions, and the second is to be subtracted from the first one. In normal numbers, what we do is we take the LCM of the denominator. So let's do the same here. What will be the LCM? You can see there are no common factors between 7 minus root 5 and 7 plus root 5. So the LCM will be simple, the product of 2, that is 7 minus root 5 into 7 plus root 5. So now what we do? We take this term and divide this with 7 minus root 5. So 7 minus root 5 is already there, so the quotient will be left as 7 plus root 5. This 7 plus root 5 will be multiplied over here. We already have 7 plus root 5. That means 7 plus root 5 into 7 plus root 5. So we can put a square here. Then we have a minus sign. Now here again we have to divide this with 7 plus root 5. This is the normal procedure. If you just do any subtraction or addition, you will follow the same procedure. So don't get scared. It is just trying to confuse you, but it is not. So here 7 plus root 5 cancelled out. We are left with 7 minus root 5, which gets multiplied over here. So we already have 7 minus root 5 and we are multiplying this with 7 minus root 5. So we can put a square here also. Right hand side, nothing, just copy it. A plus 7 by 11 root 5 into B. In the next step, we simply expand it. This is A plus B whole square. This is A minus B whole square, because in both the places we have A as 7 and B as root 5. Remember the expansion or the identities. A plus B whole square is equal to A square plus B square plus 2AB. We can use this identity to expand this. On the other hand, we have A minus B whole square, and the expansion of A minus B whole square is equal to A square plus B square minus 2AB. And here we have 7 is A, root 5 is B. So we have A minus B. Similarly, here we have 7, that is A, already seen it, plus root 5, which is B. So we got another here, that is A minus B into A plus B. This identity is A square minus B square. Just use these identities. So have 7 plus root 5 whole square. A plus B whole square equals A square plus B square plus 2AB. So we get here 7 square as A square plus root 5 square as B square plus 2 into A, that is 7 into B, that is root 5. This is the first expansion. Just put a bracket to avoid any confusion. Next, minus, open the bracket for the second expansion, which is 7 minus root 5 whole square, that is A minus B whole square, A square, that means 7 square plus B square, that will give us here root 5 square minus 2AB. A is 7 and B is root 5. Close the bracket. Divided by 7 minus root 5 into 7 plus root 5, which is A minus B into A plus B, and it is equal to A square minus B square. Such a straight, simple way to write. We have 7 square minus root 5 square. And the RHS, just copy it down. A plus 7 by 11 root 5 into B. So we are done with the expansion. Now we have to simply solve it, reduce it, simplify it, and we will be done. Now expanding it further, we get 7 square is 49 plus root 5 square is 5 plus 2 into 7 is 14 root 5. This is the first one. Then we have minus bracket. 7 square is 49 plus root 5 square is 5 minus 2 into 7 is 14 root of 5 divided by 7 square is 49 minus root 5 square is 5, which is equal to RHS. Just copy it down. No changes as yet. 7 by 11, 5b. Now let's open the brackets. 49 plus 5 plus 14 root 5. Now here we have minus outside the bracket. That means minus is to be multiplied with the signs of each and every term inside. That will invert the signs, means plus will become minus and minus will become plus. That means here we get minus 49 as it was plus 49, and minus multiplied with plus 49 gives us minus 49. Then we have minus into plus, we get minus 5, minus into minus, plus 14 root 5 divided by 49 minus 5, that is 44. Right hand side, just copy it. Nothing has been done on RHS so far because we are right now focusing at the LHS. Once we are done with LHS, we will look into the RHS as well. Now look at this. Here we have 49, here we have minus 49, cancels out. Here we have plus 5, here we have minus 5, cancels out. Now here why are we cancelling out? Because it is not in the numerator and denominator, rather it is simple addition and subtraction. 49 minus 49 is 0, plus 5 minus 5 is 0. So that is why rather than writing 0, we are just cancelling out. It is the same as writing 0. Solving it further, we get, now here we have 14 root 5 and 14 root 5. So we can take root 5 as common. We are left with 14 plus 14 divided by 44 is equal to a plus 7 by 11 root of 5 into b, which gives us root 5 into 14 plus 14 is 28 divided by 44, which is equal to a plus 7 by 11 root 5 into b. We have some common factors, so 2 2s are 4, 2 2s are 4, 2 1s are 2, 2 4s are 8, 2 1s are 2, 2 1s are 2, and 2 7s are 14. So we get root 5 into 7 divided by 11, which is equal to a plus 7 by 11 into root of 5 into b. So now LHS is almost simplified. Now we have to make the comparison. But if you look at LHS and RHS, both are appearing to be quite different. So let us try to make it similar. For example, this can be written as 7 by 11 root 5. This is the same. Root 5 into 7 upon 11, 7 by 11 into root 5. We have just changed the representation, nothing else. And this side we have a, the value we have to find out, plus 7 by 11 root of 5, and b, the value which we have to find out. Now if we see, we have 7 by 11 root 5 here, 7 by 11 root 5 here. Always consider the sign. What is left? A over here and b over here. But if you look at this side, there is no term like that. What does it mean? It simply means that this could be written as multiplied by 1. Now both the sides looks similar. But again we are left with A. A is also not there in this case, means we can simply write it as 0 plus. Now LHS and RHS both are looking similar in the same format, where we have 0 and here we have A. That means this one, and here we have 1 and here we have B. What does it mean? It simply means that A is equal to 0 and B is equal to 1. The question is easy. It's just a tricky question, trying to confuse the students so that you can just use a bit of your imagination along with the logic to derive the solution. Like here, many students would give up even in the last step, saying that we have 7 by 11 root 5 and that side we have A plus 7 by 11 root 5 into B. So it is not. No. It is already done. If there is no term as A, we can write here 0 and that will make both the expressions look similar. Same way, instead of B we can write 1 and we are done. Don't get scared. Don't lose your hopes. Just start doing it. And believe me, study mere, not anymore.